metrics for testing. So the majority of the metrics which we have seen for testing, they focus on the process of testing, what process are being adopted, but not on the actual technical characteristics of the test themselves. So tester has to do what? They have to rely on the analysis, design, the code metrics, for design and execution of the test case. So they have to rely upon all these. So the architectural design metrics provide certain information to us, like architectural design we have already seen. So what are the metrics? What information do they give? They give us information like ease or difficulty for integration testing. Do we need stubs and drivers, like the need for the specialized testing software? Do we need a main dummy program or the sub-module dummy programs? So this architectural design matrix will tell you. Along with this, the architectural design matrix gives certain more things. The cyclomatic complexity also, it will give you how much extensive unit testing you have to do. If you have high cyclomatic complexity, likely the module is error prone. So using the definition of the program volume and program level, we have already seen about Halstead metrics. When we apply it to the testing, so Halstead gives us the effort. We have volume and we have the program level. He says the program level is 1 by n1 by 2 plus n2 by n2. This is nothing but the L, the volume ratio. And this is program 1 by, because this is nothing but what? This is nothing but difficulty. As I said, difficulty and volume ratio are inversion of one another. Effort, E is effort. Effort is E, V is volume, D is difficulty. So if you multiply PL multiplied by effort will give you volume, or you can say effort is volume into the D, difficulty. Now this can be used to find out the effort, but this can be done for the whole software in terms of testing. How much effort you are going to put in. So the percentage of overall testing effort for a certain module K, now with the Halstead metric, can be computed like this. So this is the percentage of testing effort, and this is given by EK divided by summation of EI. This numerator is computed for module K for each module, and the denominator sigma EI is the sum of Halstead effort across all modules of the system. How many modules? 10 modules. So you have to do sigma 1 to 10. And this is for the module which is concerned, which we are talking about. So this is the percentage of testing effort.